Hey guys, welcome to your course Web Development using PHP and MySQL. This is Module 2, Basics of Internet and HTTP. This module consists of two videos. This is the first one of them. Let's go through the session objectives. In this video, you will learn about what is Internet, history of Internet, how Internet works, understanding IP, TCP and DNS, public IP versus private IP, and finally physical architecture of Internet. So let's start. So what is Internet? According to Wikipedia, the Internet is the global system of interconnected computer networks that use the Internet Protocol Suite, that is TCP/IP, to link devices worldwide. It is a network of networks that consists of private, public, academic, business and government networks of local to global scope, linked by a broad array of electronic, wireless and optical networking technologies. As you can see, this definition is quite complex, especially for a beginner, because it consists of so many new terms. So rather than going by this definition, we are going to create our own understanding of Internet. To create our own understanding for Internet, we will have to answer the question why Internet was needed at the first place. To answer this question, we are going back in time and dividing the entire timeline into three phases. The first one is 1965 to 75. In this era, first personal computers came into existence and people started them using for purposes like programming, research and gaming. In the next era, that is 1975 to 90, computing power increased. Graphical user interfaces came into being, which improved the user friendliness of computers. And gradually, operating systems like Unix also came into existence. Post 1990s, computing power increased even more. Software got powerful and people started using multimedia. But even in this generation, this era, people were able to use only those softwares and multimedia which were installed or stored on their own computer. At this point, people started to wonder what will happen if they will be able to access any software or multimedia stored anywhere in anybody's computer. This particular idea was the first seed of Internet. With that understanding, let's answer the question, how does the Internet work? Let's assume Internet to be a giant pipe. A pipe passing through everybody's home. It's ubiquitous. Using that understanding of Internet, let's create a simple model of how various computers connect to Internet. This is our giant pipe which passes through every home. This is your computer and this is how you connect to the Internet. This is somebody else's computer, maybe your friend's, and this is how he connects to the Internet. And similarly, every other computer on the earth is connecting to the pipeline like this. This is the simplest model of Internet. To improve that model, let's break the term Internet into two terms, interconnected and network. So what exactly is interconnected network? Suppose we have a network of 4 computers and we are calling it as network A. This is another network of 4 computers and this is called as network B. But what will happen if one computer from network A is connected to another computer of network B? The resultant output is known as interconnected network. Now, let's implement that understanding to create a new model for Internet. Let's take our networks, network A and network B, and rather than connecting them with each other, let's connect them to the giant internet pipe. This is what internet is. Network of networks. You can see many other networks like network C, D, etc. also connect to the network pipe like this. This is how the internet works. To understand internet even better, we have to understand something called a server. So what exactly is a server? Let's take a simple scenario where you as a user wants your Facebook profile page on your computer. So you take out your computer and you type facebook.com on your Chrome browser. And within a few seconds, you see your profile page displayed on your computer screen. So now the question arises, was the page previously on your computer? Was it stored on your hard drive? The answer is no. It was not stored on your hard drive. So where did it come from? The answer is it came from Facebook's server. So what exactly is a server? In simpler terms, a server is nothing but a computer which hosts files which are being demanded over internet. So any files related to Facebook are stored on this computer, also known as Facebook server. So what is the difference between a normal computer and a server? There are two major differences. First, the server runs a special software which helps him to handle multiple requests from clients. The second thing is it has slight different hardware which helps him to work properly. So what is different? The server consists of a bigger cache memory so that it can store more data in the cache for faster recall. The server's CPU also consists of multiple cores to break down the task. It also consists of hard drives to avoid disk failures. It also consists of backup power systems to ensure continuous availability. And of course, it consists of faster RAM for faster execution. Now, with our own all understanding, let's take a typical use case where a user is demanding his profile page from Facebook, and let's break down the entire steps into smaller pieces. First of all, this is our internet pipe which goes through every house. This is your computer, the client's computer. You type www.facebook.com. That request from your computer goes to your router. From the router, the request goes to your internet modem. It can be anything, either your broadband connection or your Reliance Jio dongle. The request from the modem goes to your ISP. ISP is your internet service provider. It can be City or Reliance Jio or Airtel. The ISP transfers your request to internet. From the internet, the request goes to the Facebook's internet service provider, and from there, the request finally reaches the Facebook server. This is how a typical internet request works. A few questions arises at this point of time, like how will my computer find Facebook server on the entire internet? How are files actually transmitted over internet? And finally, what makes the overall process this? Let's answer the first question. How would I find a computer over the entire internet? This is a very logical question and a very obvious one. There are millions of devices on internet. How would my request going from my computer reaches a server stored in or located in US? The answer to this question is Internet Protocol. IP or Internet Protocol is a protocol. Simply said, a protocol is a set of rules governing how things work in a certain technology, so that there is some standard kind of standardization. When put into network communication context, an internet protocol describes how data packets move through a network. When you have a protocol, you are sure that all machines on a network or on internet, however different they might be, speak the same language and can integrate into the whole framework. The IP protocol standardizes the way machines over the internet or any IP network forward or route their packets based on their IP addresses. To put this simply, the IP address does basically three things. It divides the information to be transmitted into smaller data packets. The second thing that it does is addressing. For every network device or a router or a server, it assigns a unique address, which is also called as an IP address. So basically, your data packets are transmitted over internet from one server or router to another. This process is also called data hopping. The third thing that IP does is routing. Suppose from going from one computer to another computer, there is a network congestion. So the next data packet will not travel from that path. In the above diagram, you can see the white lines are the path where there is less traffic, and the red ones are with high network congestion. And as you can see, the blue lines shows the data packets. So it's not necessary that all the data packets will follow the same path. Depending on network congestion and other factors, data travels from separate paths but reaches the same destination. Every data packet consists of three things. First, the information that it is carrying. Second, the IP address of the machine to which it has to reach. And third, the IP address of the machine from which it's coming. Now, let's shift our attention to IP addresses. As we said, every unique machine or server or router on internet has a unique IP address. Let's understand what exactly is an IP address. An IP address is a numerical label assigned to each device connected to a computer network that uses the Internet Protocol for communication. An IP address serves two principal functions: host or networking interface identification and location addressing. Up until now, there are two different types of IP addresses available. The first one is IPv4 and the second one is IPv6. On the left side of the screen, you can see how a typical IPv4 address looks like. It consists of 4 different dotted decimal notation numbers, each ranging from 0 to 255. Now you can see at one point of time there are only 2 to the power 32 possibilities of unique IP addresses, and you can see there is a huge number of devices connected to internet at any point of time. So we are at a shortage of IP addresses. To overcome this problem, the Internet Consortium has introduced a new nomenclature, that is IPv6. It consists of 8 different hexadecimal numbers, which gives you enough possibilities that will never run out of addresses. Now the obvious question arises: who on internet assigns IP addresses? The answer is your internet service provider. Your internet service provider assigns IP addresses to every computer connected on its network. Now, this is a very important section where you will learn the difference between public IP and private IP. Let's take a simple scenario. This is your home, which consists of a router, and the router is connected to internet. And because of the IP, the internet service provider, your router has got a unique IP address over the internet, that is 202.142.68.253. Now, this is your computer, this is your parents' computer, and this is your siblings' computer. Now, on your home network, your computer has an IP of 192.168.0.113. Your parents' computer has 192.168.0.10, and your siblings' computer has 192.168.0.49. But whenever any one of you will Google what is my IP address, you will see 202.142.68.253 as your IP address and not the one mentioned below your computer's name. What are these IP addresses? In this scenario, the router's IP address is the public IP address. For all the devices connected on the same network, every device will have the same public IP, that is 202.142.62.253, and all the IP addresses which are provided below the computer's name, they are called the private IPs. These IP addresses are provided by your router so that it can communicate with each of the devices comfortably. Let's see this with a demonstration. Let us find our computer's IP address using our command prompt. You have to open your command prompt and you have to type a command called ipconfig. Once you press enter, you'll get a lot of information, and you will also see an IP address which says 192.168.59.7. This particular IP address is my private IP address, which is provided by my router. Now let's go to Google Chrome and let's type what is my IP address. And now you can see your public IP address to be displayed as 202.142.113.217. This is completely different from your IP address being shown in your command prompt. This is the difference between your public IP and private IP. Now, the obvious question that must be arising in your minds would be, how would I remember so many IP addresses? That is, if every device, routers and servers on internet have a specific unique IP address, how would I call for a specific computer or server among so many devices? The answer is domain name servers. You can understand or take domain name servers to be dictionaries which have IP addresses at one side and their respective names on the other side. Suppose you want to find the IP address of google.com. You just have to type www.google.com on your computer. That request will travel from your computer to a domain name server, which basically is just a computer. And that computer will have a huge list of all the websites and their respective IP addresses. It will take the string www.google.com and matches it with its database and gives you the IP address as the output. Now, let's answer our second question. How are the files actually transmitted over the internet? The answer is Transmission Control Protocol. When Transmission Control Protocol couples with IP, you get the Internet Highway Traffic Controller. TCP and IP work together to transmit data over the internet, but at different levels. Since IP does not guarantee reliable packet delivery over a network, TCP takes the charge of making the connection reliable. TCP is the protocol that ensures reliability in a transmission, which ensures that there is no loss of packets and the packets are in the right order, that the delay is to an acceptable level, and that there is no duplication of packets. All this to ensure that data received is consistent, in order, complete and smooth. During data transmission, TCP works just before IP. TCP bundles data into TCP packets before sending into to IP, which in turn encapsulates these into IP data packets. As you can see on your screen, this is a simple image which is first divided into smaller modules by the TCP, and then it is converted into IP data packets and transmitted over the internet. And once it reaches the destination, it is reassembled into the original picture. This is how TCP works. Now, let's answer the final question. How is the internet so fast? If you type facebook.com on your computer screen, you get the entire page within a fraction of seconds, even though that page was stored on Facebook servers, which is located in US. The answer is electricity, light, or radio. These are the three mediums which are chosen to transmit the data from one place to another. Let's decode them one by one. The first one is electricity. You must have seen these sort of LAN cables in your internet college campus or hostels. These are high-speed devices in which data is being modulated on top of electrical signals and transmitted from one place to another. The disadvantage of this particular method is that the data reliability is not very good on very large distances. The second way of transmitting data over long distances is optical fiber. As you can see, these are optical fibers which are being shown on your screen. If you want to send data from one place to another using optical fibers, what you do is you modulate your data signals on top of light waves and send them through the optical fiber network. In that first image, you can see one bit of information being transmitted through the optical fiber pipe. And in the second diagram, you can see 2 bits of information are being transmitted by just changing the reflective angle of the light wave. This diagram shows the entire optical fiber network in the world. These optical networks are beneath the sea and they span the entire world, and they provide the seamless delivery of content over internet. Last but not the least, radio waves are used to transmit internet data signals from one place to another. These are transmitted using giant towers. You must have used this sort of communication when you use your mobile data for connecting to your internet. The typical ISP providers are Airtel or Reliance Jio. Thank you.